Hello. So we're gonna go ahead and talk about machine learning today. All right. So the second video. All right. So when it comes to machine learning, or at least machine learning algorithms, it's ideal for us to first define what's machine learning, which is using information to make predictions/decisions. You can go online and find more complicated definitions, but this is pretty much it. And then when it comes to an algorithm is a process or a procedure that is followed to get a result. Kind of like a recipe. So like making a cake, right? You have to have your ingredients and you have to follow a certain procedure. Replacing a tire, there's one way that you have to replace the tire. You have to do certain steps. Preparing taxes, as you business majors know, in biz law, you have to do certain things. And so what's common theme here is that you have to do a procedure to get a particular result, right? You have to do a procedure. What's really interesting here is that there are a lot of ways of doing the same thing, right? Which is nice, but in certain situations, you just have to use one. That reminds you, if you have me as an instructor before, you know my famous saying: "Many ways to the top of the mountain, choose one. Many ways to the top of the mountain, know many." KNOW, many. So in this class, we're going to learn about machine learning algorithms. And if you're taking a stat class at Cal Poly or any other department, you are already familiar with a few of them. So let's go ahead and continue. So when it comes to types of machine learning algorithms, there are three different types. Okay, there's supervised learning algorithms, unsupervised learning algorithms, and reinforcement algorithms. Mind you, this image is not mine. It's from the Dataflare website. I am not getting sued. So that being the case, when it comes to supervised learning, that's going to be the main machine learning algorithm that we're going to use in this 2-week session. That's going to be the only one. However, we're going to discuss unsupervised as well as reinforcement learning. So let's just briefly touch on it. So supervised learning, at the end of the day, you have a response variable. So classification, where you have a categorical binary response, or regression, you have a quantitative response, okay? And you use your explanatory variables. I'm going to throw something at you, predictors, to try to predict your response variable, okay? Trying to predict your response variable. However, in terms of unsupervised learning, that's when you don't have a response variable. You don't know what your aim is, but you're trying to understand the data. So one of the ways is trying to reduce the dimensionality of your data, trying to not have so many variables, or you're trying to cluster your variables in such a way that you can analyze your data more. And last but not least, my ultimate favorite is the reinforcement learning. So when you actually have an environment, essentially you're trying to learn how to maximize your a particular objective or your something that you're interested in. In that particular situation, I'm dealing with variables, but we'll go a little bit more in detail in a little bit. So let's continue. So when it comes to supervised learning, a more succinct definition is when you know your response variable and you're using explanatory variables to make predictions on your response. If this is a stat class, I would say explain, but this is not a stat class. So we're trying to make predictions on the response variable. Some examples of this: let's say you're a creditor. Okay, you're a creditor and you want to determine individuals' credit scores based on their debt to income ratio. Our response variable will be your credit score. Your explanatory variable would be your debt to income ratio. Okay. So another example of supervised learning, let's say you're a botanist, right? You're interested in classifying species. You have a plant and you have the length of the plant. So you're trying to use the length of the plant to predict the actual species, right? And so your response variable is going to be the species of the plant, and then the explanatory variable is going to be the length of the petal. So with that being said, supervised learning. For the most part. Unsupervised learning. So unsupervised learning is when you don't have a response variable, when you don't have a variable of interest. So you can either be trying to reduce the number of variables that you have, or you're trying to cluster your information together. Example 1, a group of students. You have a group of students and you collect their information about the students. You have their GPA, hour studies, distance from home, number of units enrolled, number of hours working, and the number of Facebook friends. I just threw that one in there. And you're just trying to understand the data. And so you'd use an unsupervised learning algorithm to analyze that data. Or you're conducting a community survey, okay, in San Luis Obispo regarding health habits, health and exercise habits. You collect blood pressure, number of doctor's visits per year, number of times they've been to the gym, age, height, weight, all these other variables. And again, you don't know what is of interest, but you want to understand the data anyway. So that's an unsupervised. This is when you would want to use an unsupervised learning algorithm. Again, we're not going to do this in this class. And last but not least, my favorite reinforcement learning is when you have an agent and you're trying to make, or at least you're making actions to obtain a certain reward, okay? In most situations, you're trying to maximize that reward. And essentially, it's learning by doing. Just learning by doing. It's trial and error. And so, for example, you're trying to get a customer to buy a car, right? You're going to try to get them to say, I don't know how to sell a car, but you get the point. You try different things to get a particular outcome. Or you're trying to sell a bunch of cars. You try different selling mechanisms to sell that, get that reward of selling that many cars. What I'm doing now, teaching students, what I love to do, I would say this is reinforcement learning. At least with me, if you had me as a student, if you had me as a teacher, you'll see that every quarter, or at least you had it twice, at least twice, at most twice. I evaluate myself by giving end of the year surveys, and I look at that data every single time. And so I try to get better. And so that's an example of reinforcement learning. That's why it's my favorite. And so that is it for machine learning today. We'll go a little bit deeper tomorrow, and thank you for your time.